that will be meta-directing. Okay, electron releasing groups or donating groups will increase the electron density in the benzene ring. Now electron withdrawing group like NO2 or CN or COOH, these groups on the benzene ring decreases the electron density. So that is why these are meta-directing. These are what directing? Meta-directing groups. Okay. So I think you are aware of ortho, para and meta direction. What is ortho position, para position, meta position? So electron withdrawing group are meta directing. Why? Because if you keep an NO2 group, then ortho and para positions you will get positive charge. You will get a positive charge on the ortho and para positions. So that is the reason this bond will migrate like this. So this bond will migrate like this. You will get a double bond N, O minus, coordinate bond O. Like this, positive charge will be coming on the ortho position. Means comparatively, meta position is electron rich. Here ortho para positions are electron rich. Here if withdrawing group is there, then ortho para positions you will get a positive charge. So comparatively electron density is more in which place? Meta position. Okay, means here meta position electron density is not increasing, children. One point you have to remember. Ortho and para position positive charge is there. Because of that, somewhat electron rich. This one meta position. So the next coming electrophile will attack at meta position. Okay. So this effect is called as orientation effect. What is orientation effect? Already presented group will decide the next coming electrophile. You go ortho direction, you go para, you go meta, like that. It is directing the other incoming thing. So that is called as orientation effect. So whenever these groups are there, if you do any electrophilic reaction, they will come at meta position. Okay. Next one. Electron releasing group donating. Now, which are strong donating, which are weak donating, what is their effect? I will give you one table so that will be easy for you to remember. Okay. What are strong donating, very strong donating? One exception is also there for halogens. That also we see. Understood, children? What are donating group? One stand up and say donating and withdrawing.
The group which can increase that electron density in
very
the
good.
benzene nucleophile is electron donating.
Okay.
Decreases.
That is what? Electron donating is?
Donating.
Is which direction?
What?
It is with directing, ortho para directing.
It is ortho and para.
Like that. At a time you tell the same things. Next one.
Electron withdrawing is which decreases the density.
So?
And which is meta position.
Which is meta directing. Right. See. So now we will see which are strong electron withdrawing, which are strong electron donating. This tabular form I will give you. So this is the first column, groups I am talking about. And here the nature, whether they are strong donating or weak donating, nature. And after that directing, which directing they are. Okay. So first one, if you take O minus is very strong donating. After that NH2. After that, see last bench, can you able to see? NHR greater than NR2 greater than OH. So these are very strong donating groups. Which are very strong donating groups. So they are which directing, children? OP directing. Ortho para directing. This is the first serial number. Now second. Understanding? O minus NH2 amine group, secondary amine, tertiary amine, like that. These are all very strong donating. Shortcut. VST means what? Very strong donating. Clear? Now If you take CH3, OR ester groups, and these three right. OR group and NCOR and HCOR and OCOR. So for benzene ring, if NHCOR is there, means that is called as acetanilide. Okay, you will tell no. Aniline, if the group is attached to NHCO3, then what you say? For this is called acetanilide. Have you heard about it? Aniline, acetylation. So that group this is NHCOR. These are just strong donating but ortho-para directing. Just strong donating. OR. OH is very strong, OR is somewhat strong. Next, third one. Alkyl groups, alkene group and benzene group. These are just donating. These are also ortho-para directing. See, very strong, strong and donating. Now this is exception, children. Fourth point is very important. Halogens. Halogens. Chlorine, chlorine, bromine, iodine, or CH2X group or CHX2 group. These are withdrawing groups. These are what? Withdrawing groups, but OP directing. This is the exception case. Generally what I told, donating groups are ortho-para directing and withdrawing groups are meta-directing. That is general sense. But this category, halogens are withdrawing groups but they are OP directing. Because of two reasons. It has minus I effect and also plus M effect. Okay, that together called as tautomeric effect we will say. But anyhow, if they are in benzene ring, which effect we will consider? Inductive effect only. I am repeating the point. Whenever halogens are present in the benzene ring, it has two effects. One is minus I, other one is plus M. Okay. So plus M is dominating, that is why OP directing there. But we will consider what? Inductive effect only. Whenever benzene ring is there, we will consider inductive effect. In compared to acidity and all that, we will see only inductive effect. But the next coming electrophile, reactivity wise, it will go ortho-para direction. Why? Because chlorine has 3 lone pairs. Now fourth point clear, children? Now fifth point. Donating. Now withdrawing nature you will see. Withdrawing, what else are withdrawing here? Aldehyde group, you can take. Aldehyde are there, no? Ketone group. Ketone. Aldehyde, ketone, acid. You can take ester. After that, acid chloride. Next, cyanide. These things are strong withdrawing. So these are which directing, children? Meta directing. And last one more line is there. So donating, very strong donating and donating. Here withdrawing, strong withdrawing, and one more is there, very strong withdrawing groups. What are those? So these all are strong withdrawing only. Shall I write up the last point? Can you able to see? This is aldehyde, ketone, acid. Okay. Last group is there, that is NR3 plus NO2 plus NR3 plus NO2 plus NO2, not NO2 plus NO2. So these are, you can write NHR3 plus R2 plus also. So nitrogen bearing a positive charge will become very strong withdrawing, children. This is very strong withdrawing. Last, very strong withdrawing, and it is also a meta directing. Means suppose I have taken nitrobenzene and I did nitration. So which product will come? First bench, nitrobenzene I have taken and I did nitration. You will get ortho, nitro, meta, what will get? Nitrobenzene ko nitration kiya. Nitrobenzene is there. I did nitration. So meta dinitro product will come. Okay. Meta dinitro product. Okay. Suppose I have taken toluene and I did nitration. Now ortho and para nitro products will come. Okay. Like that. Ortho and para will come. So chlorine is there. I did nitration. Then what will come? Chlorobenzene is there. Yes, second bench, can you try? Chlorobenzene is there. I have done nitration. Meta, see, chlorine is which directing? Withdrawing group, but ortho para, right? So ortho chloronitrobenzene and para chloronitrobenzene will come. And it's para isomer. Understanding, children? So this is about electrophilic substitution and yesterday I told you free radical substitution. Now we will go for nucleophilic substitution reactions. Okay, some more points are there. If benzene is having one electron and one donating group, what happens? If two donating are there, two withdrawing are there. Those points I will tell, and then we will go to the next topic. Don't worry, 4 days we will complete it. Types of reaction. Study well. 4 days. Yesterday we started. Today, tomorrow, and this week we will see types of reactions only. 4 days maximum we will spend. So that maximum points I can cover. Right. Everyone completed? Everyone? Okay. Now write some 3 note you keep. Note में लिख दो. पहले first point. If there are donating and withdrawing group in the benzene ring, if there are donating and withdrawing group in the benzene ring, means what? Donating and withdrawing, what is the other name? Activating and deactivating. Right there also. If there are donating and withdrawing group present in the benzene ring, means what, children? Activating and deactivating. Activating means donating. Deactivating means withdrawing. If they are donating and withdrawing groups present in the benzene ring, then the position of the electrophile, will be decided by activating group. Will be decided by activating group. Then the position of the electrophile is decided by activating group. So suppose this is there. What is the name of this? Phenyl benzoate. Phenyl benzoate is there. So this is which group? Withdrawing group. And this is donating group. Then if I added any electrophile like Cl plus or R plus, anything, any electrophile, then at which position it will come, children? See the point, study and tell which position it will come. This is donating group O minus. This is withdrawing group CO. So according to which it will come? Donating. So donating group ortho position is here, no? So they will ask here, benzene ring, which benzene ring the electrophile will come, like that. So you have to say here electrophile will come. Whatever may be the electrophile, that will come and attack at this position. Because this is ortho position, this is para and this is meta. Understanding? Next second point. Write the equation. If both groups are present, if both groups are deactivating, deactivating group, if both group are deactivating group, then the position of the next coming electrophile is decided by, then the position of the next coming electrophile is decided by, if both are, Niranjan, what you wrote? If both are deactivating group. If both are deactivating group, then the next coming electrophile will be decided by strong deactivating group. Then the next coming electrophile will be decided by the stronger one. If both deactivating groups are attached to the benzene ring, both the groups are deactivating, then the position of the next coming electrophile is decided by stronger one, stronger deactivating one. Next one, third one. If both groups are activating, if both groups are activating, if both groups are activating, then the next coming electrophile is decided by strong activating group. Then the next coming electrophile will be decided by strong activating group. That's all. Okay. Next, keep the heading nucleophilic substitution reactions. Nucleophilic substitution reactions. So this you studied in alkyl halides also. This is the third type of reactions in substitution. Today we will do only this. Nucleophilic substitution reactions. So these are how many types? I won't tell more. SN1 and SN2, right? And SNI is also there. So in SN1, first we are talking about SN1. SN1, what happens? A tertiary alkyl halide statement you write. Tertiary alkyl halide on hydrolysis, alkaline hydrolysis. Tertiary alkyl halide on alkaline hydrolysis gives tertiary alcohol. This is the statement. Anything you can take, I have taken this. Tertiary alkyl halide on alkaline hydrolysis gives what? Tertiary alcohol. Okay, this is tertiary thing. R group is 3 degree. So what will be the statement? What will be the reaction? RX, whatever may be the nucleophile, will form RNU plus X minus. This is the reaction. Right? It is a two-step process. It is what? It is a two-step process. Mechanism. So step 1 is what step? Tell me. Ionization step. Ionization step means RX will get ionized. So RX means here I am taking a tertiary alkyl group like R1, R2, R3 and X. So this will undergo ionization step. R1, R2, R3. Plus X minus. So this is reversible and also slow step. So this is called as RDS. Again I will tell. First step is ionization step. Ionization of alkyl halide. So what are the points? It is a slow step and it is RDS, means rate determination step. Understanding? And what is the intermediate in this? Carbocation. So if they ask L1 reaction in which carbocation is formed, means this one you have to say. Clear? Now, step 2. This is the first step, ionization step. Ionization of alkyl halide takes place because of the solvent. The solvent will break the bond between R and X. You will get a carbocation. So second step is nucleophilic attack. It is a fast step. It is a fast step. First step is slow. Second step is nucleophilic attack, that is fast step. So what happens? This formed carbocation is, what is the shape of this, children? What is the shape of carbocation? It is planar. So the nucleophile can come either from front side or from back side. It may come in both ways, or you can say above the plane and below the plane. If I keep the plane like this is my hand. So left and right. If I keep the plane like this, above and below, both attacks are possible. So we will get two products, children. One is R1, R2, R3. Here nucleophile will come. This is called retention. And the next one, nucleophile will be here. R1, R2, R3. This is called inversion. So one is retention, other one is inversion. What do you mean by retention? Can you able to see last pages? What is retention? See, where the X is there only nucleophile is coming, that is called retention. Means configuration is retained. अगर X यहाँ था और nucleophile opposite में आ रहा था, तब वो inversion. Understanding? So both products are formed. So if very less chance is there, if equimolar products are formed, if retention and inversion are an equimolar ratio, 50%, then it is called as racemic mixture. If you get 50% R and 50% S, retention and inversion are 50%, then that mixture is called as racemic mixture. But generally, this is formed in rare cases only, racemic mixture, not every time. So majority of the cases, partial racemization takes place. What will happen? Partial racemization takes place, in which inversion product is more than retention. Inversion is more than retention. This is also reason is that intimate pair of it. Okay, just to remember, inversion product is greater than retention. That is called as partial racemization. Most of the cases, partial racemization takes place. Is it clear, children? It is a two-step process. SN1 means two-step. It is called unimolecular nucleophilic substitution. First step is slow step. Second step is fast step. This is ionization step, and that is nucleophilic attack. Is it clear? Everything? Now, I'll tell the graph of this. Then we will see the factors affecting this. Okay. So what will be the graph? Energy profile diagram. Here energy and here reaction progress. If you take reaction coordinate or reaction progress, so the graph will be like this. Okay, and this is RX ionization step. RX and nucleophile will be there. So at this step, RX bond will be partial ionization, plus and minus. Here you will get a carbocation. So once carbocation is formed, it is stable, no? So the energy will be less. See, among these four, the energy will be less here, R plus. After that, the bond between R and nucleophile will take place, and finally, strong bond is formed. So this is the reaction progress of an SN1 reaction. So what is the intermediate formed in SN1 reaction? Children, what is the intermediate formed in SN1? Previous question, they asked, what is the intermediate in Reamer-Timmer reaction? Dichlorocarbene. That is previous NEET question, previous competitive question. Like that, here next time they may ask, what is the intermediate in SN1 reaction? Carbocation is the intermediate. So whenever there is a formation of carbocation, it is always a chance of rearranging it. Okay, rearranging means less stable carbocation rearranges to more stable. So there is always a possibility of rearrangement if it is less stable. So whenever a carbocation is formed, there is a chance of rearranging itself into the more stable one. So one point is clear, rearrangement is possible in SN1 or not? That point you have tried. Rearrangement is possible in SN1 reaction. Rearrangement is possible in SN1 reaction. Next. Now we will see the factors which are affecting SN1 reaction. So in these factors we will study more points.
This rearrangement of carbocation is very important thing to remember.
Yes, sir. In reactions I will tell you.
You may expect some product and the actual product will be different.
I will tell with the examples.
Generally what now? Please.
Okay.
We will tell you the example also of rearrangement. So expected product
Is something
and the
like
actual
that.
product, they are different. Let's see how it goes.
See, suppose here Cl or Br is there, alkyl halide, no? You can take Br. So what we expect here, if OH minus is there, means you think that it is a nucleophilic reaction and the expected product is this CH3, CH3, CH2, OH.
OH. This is expected. What we will do, we will take out Br and put OH.
Expected.
The actual product is different.
But here what is the first step, children? First step you will get a carbocation, ionization of alkyl halide takes place. This one, this is a 1 degree carbocation, and here next carbon hydrogen is there. So there is always possibility to shift hydrate or methyl. So in this case hydrate shift takes place, H minus, it is not H plus. H minus will go here and you will get a 3 degree carbocation which is more stable, you studied. So why 3 degree carbocation is stable? Hyperconjugation and inductive effect, plus I effect. These are the two factors. So after that only our nucleophile will come, OH minus, and you will get a tertiary butyl alcohol, but not that product. This is the real product. And one more time also.
Okay. Expected product was this. What he is saying is absolutely right. Carbocation will be formed. This is 1 degree of primary carbocation. Tertiary is more stable. So it will rearrange itself to tertiary ion. And then OH will be corrected. So actual product is this.
So one more case also you can see. You try this product now, I will see who will do correctly. Yeah, this one you do it, and children, what will be the product?
This question has repeated 3 times. 3 times in NEET. Such a type of question is repeated. Rearrangement of ion.
This one you have. Those who have written, raise your hand, I will come to you. This one and one more example also. Those who have done that, you do this.